Well, that brings us to our next little tool, SED, which is our stream-oriented text editor. And this is a Unix filter that includes all of the grep stuff, but allows us to not only find patterns, but then programmatically change them to something else. So this is a great tool for writing conversion programs to convert large files from one format to another, like data input files. And this gets especially powerful since we can run it in a large cluster in parallel on files of almost any size. So if I have 10,000, a big cluster with 10,000 servers and 40,000 disk drives, I can take a many terabyte file and transform it in literally a minute or so, where it would take days on a single computer. So the way SED works is it has a pattern space, or a workspace or temporary buffer where a single line of input is held. So this is what we think of the pattern space here. And a hold space, a secondary temporary buffer for temporary storage only. Now, most of the time, we don't have to think that much about this, but only when we get into really complex kinds of SED stuff. So here's my pattern space, and I'm going to issue that pattern space match against every line in my file. Or I'm sorry, the script file is going to contain a whole bunch of pattern spaces that I'm going to match against my input file, which is here, to transform it into some output file. So a script is nothing more than a file of commands, and each command consists of up to 2 addresses and an action, where the address can be a regular expression or a line number, and the address is going to be like grep. It's going to tell us what lines to actually do something on. So if the address matches, then we're going to do what the action is. Many times you don't have an address which says, hey, do this on every line in the file. So as SED goes through the file, it reads a line in the file, then it reads the first command of the script and checks the address against the current input line. There's a match, the command is executed. There's no match, the command is ignored. It then repeats this for every command in the script file. So you have basically a file or a sequence of editing commands, and these get applied sequentially to every input line. When the end of the script is reached, SED outputs the current line, the pattern space, unless the -n option has been set, which says don't output it, and it goes on and reads in the next input line and starts at the beginning of your SED commands again. So it's just a very simple process. So all commands in the script file, right, here's my script. Here's command 1, command 2, command 3, command n. So here's our input. Line by line, each line goes through this pipeline of commands, which can do multiple operations on it, which is very powerful. So I can do one transformation and then another and then another and then another. And then that goes to the output line. So SED commands look like this: address, comma, address. Address specify the lines in the input files to which editing commands are to be applied. So I can say, 5, 12 will only run these commands on the 5th line through the 12th line. So sometimes this is handy if you want to skip the first line in a file, because maybe it's a header line that has some metadata in it, or the last line, or some sequence of lines. Not will negate that. So 5, 12 exclamation mark says, hey, do this to every line in the file except line 5 through 12. So 1, 1 exclamation mark would run our commands on everything but the first line in a file. So let's say I have a CSV file, right, that has a header. I've dumped it from Excel, and the first line is the column headings, and the rest of the lines are the data. a simple sed command that says, hey, output every line but the first line. And the command doesn't have to be anything. Just it's 1, 1, bang, and basically no command, and it will output every line but the first line in the file to the output. All right, so you can use this a lot to strip off first lines, the first 5 lines, the last line, whatever. You can also, as we'll see, use this to filter lines that have bad input on them, lines that don't have the right number of fields, for instance. So we'll see some examples here in a second. So the address could be a line number, some line 1, 3 or whatever, or a pattern enclosed in slashes. So /pattern, /pattern / says, okay, look for this pattern in the file, just like a grep, right? So sed, just with this command alone, this becomes a grep command. So grep that file for this pattern, and then for every line that matches, or you can negate that to every line that doesn't match, do the editing expression, right? So the pattern is described using regular expressions. $sign and top hat and all that stuff work. So the most examples we'll use is if no address or pattern is given, it does it to every line in the file. If only one address is given, the command operates only on that line. So we don't have to do 1, 1, we can just do 1. If we have comma separated addresses, it'll do the range inclusively between that first and second address. So everybody should now have the idea. We can choose which lines we want to do the editing on 2 different ways, right? One is specifying the actual relative address in the file, or we can have a pattern that selects out, using a grep-like search, the lines that we want to do something to. So some other command line flags that we're going to use with sed. -n says only print the line specified with the print command, or the p command of the substitute s command. Or -e, which is the one I use a lot, is the next argument is an editing command rather than a file name. So you can just do -e and then a sequence of substitutions, for instance. Or if you have a really lot of different operations that you want to do on a file, on every line in the file, you'll typically put it in a script file. And if you want to do the -n, you can put a £sign in the first line of the script file. There are a bunch of other commands: delete, print, transform, quit, substitute, append, insert, and change. We're going to be focusing on substitute because that is the one I think you do most often, although delete might be another one. So just look at the delete. So I want to delete the address lines from the pattern space. So some address followed by a D. Just skips that. If it matches, it skips that line. So sed 2d demo.txt will delete line 2. Sed the pattern beginning of line, end of line 5d will delete the first blank line. Right? This matches the first line that has nothing between. There are no characters between the beginning of the line and the end of the line, and ends with line 5. Interesting. I'm not sure why I'd want to do that, but so here's another example. Sed beginning of line indicator, capital F, lowercase u, asterisk n. So that matches F followed by 0 or more u's followed by n. That's the first. That's where to start. Right? So that's matches these guys, fn, fun, fun, whatever, up until the line, the first line that ends with a digit. So here's the ending line, and some digit 0 to 9, any one of them. Delete it. Right? So this is pretty powerful stuff here. You can do really powerful things. So the print command can be used to force the pattern space to be output. So here's address 1, address 2, P. And note that this is saying to print it, but since it's going to print automatically, unless we don't use the -n option, we're going to get the line twice. So sed -n 2p demo.txt will display line 2 only. Sed 2p demo.txt will display lines 2 twice, once because of the match and the other one because of the p. So sed -n beginning character, end character, so this is matching a blank line, right? And this $sign is the last line of the file now, right? Because it's not. So this will display the lines from the first blank line through the last line of the file, and it's going to print all the lines that match, and only print them once because of the -n. So, but here's where we get, I mean, certainly, I don't know, I don't use many of those options. The one I tend to use most often is the substitute command, which is a search and replace operation where we can either replace one or some up to 512 occurrences to replace, or G, which is the one I tend to use all the time, which is replace all occurrences of search in the pattern space, or P, just print the match, basically. So here's a simple example. Sed, quote, S Unix Linux demo2.txt. Substitute Linux for the first occurrence of Unix in a pattern space. Sed, quote, Unix Linux 2. So substitute Linux for the second occurrence of Unix in the pattern space. Right, so S Unix Linux G, substitute Linux for all occurrences of Unix in the pattern space. Right, so sed 2, $, substitute Unix Linux G, demo.txt, all occurrences of Unix in the pattern space from the second line to the last line. And then we find this is getting pretty powerful now, pretty tricky. We can also use several special characters in the replacement string. So I'm searching for something and I'm going to replace what I've found with something else. So the ampersand in the replacement string indicates I'm going to replace the entire string matched in the regular expression for the pattern. So I want to do something, I want to find all words, I want to find all the Normans, all the word patterns Norman, lowercase N-O-R-M-A-N, and I want to replace it with Norman space white, uppercase N, uppercase W-H-I-T-E. Right? So I can, well, now I want to do lowercase Norman, white. So I can search for Norman and replace Norman with the ampersand will replace Norman space W-H-I-T-E. And remember those sub-expressions we talked about last time and at the beginning of this session? We can also refer back to which pattern matched, which substring matched, and refer to them using backslash. So the ones that matched with the backslash open parentheses and forward slash backslash close parentheses. If I have multiple of those expressions that matched, I can refer to them by their number, \1, \2, \3, \4. And \:colon is used to escape the ampersand and the backslash, so we can get them in the patterns and replacements. So here's an example. Substitute .ni by wonderful .ni. Well, so this is going to match any character followed by ni followed by any character. and it's going to replace it by wonderful. So whatever this is going to be replaced by wonderful space that, because the ampersand refers back to whatever matched here. So now let's try a substring match, and by now your brains are overflowing probably, and your head's about to burst. But just try to follow along here for a few more seconds to look at these substrings. So here's a match of, now this is an open substring of a character repeated 0 or more times. So this is any character, followed by a colon, followed by a character repeated 0 or more times, and that's the end of the substring. This is the end of the first substring, and that's the end of the second substring. Right? So here's one match, which is basically all the characters before a colon, and this is another match, which is all the characters after the colon, and we replace them with \2 :\1. Right? So we were essentially finding any place we have a colon, put the stuff in front of it, after it, and the stuff after it, before it. So every time it matches anything followed by a colon followed by anything, and it follows anything before a colon followed by anything, it puts the stuff in front of the colon, after it, and the stuff after it, before it. So what's this guy doing here? So this is substitute the number 0 to 9, 1, 2. So it has to appear at least once or twice. So this is the digit 0 to 9, at least one of them, but no more than 2 of them. That's the first sub-expression, followed by an escaped /, right? So that matches, this first thing matches 0/, 00/, 01/, 1/, 9/, whatever, followed by that same pattern again. So the second one is again something, 1 or 2 digits followed by a slash. And again, the third match, the third sub-expression is again 1 or 2 digits followed by following a slash. So this looks like MMDDYY, right? So if I have MMDDYY, month, day, year, it's going to be year, month, day. So it's flipping them. Something you might want to do quite often, actually, as you get data in from different countries where they express their dates and stuff in different ways. So that's it for grep and sed. By now you should have some idea of how powerful these commands are, and how, if you really know how to use them, you'd use them a lot to transform data. The next session is going to take us one level further into the world of awk. Because the one thing that we couldn't do here is operations. First of all, we can't do any computations. Notice that we couldn't add things up, we couldn't sum things, we couldn't do any kind of arithmetic here. We also couldn't do operations across multiple lines. Well, we could a little bit, but I didn't tell you how to do that. When we get to awk, we'll see we have a whole nother level of power that you should know about, that you simple awk programs are only a couple of lines, and they can be very powerful, but they are programs. For them, you have to think procedurally. So the next session, the next video session, will be on advanced sed and mostly on awk.